Today we'll be discussing JEE Advanced 2021 Mathematics Paper 1. Now the first question is, consider three sets E1, 1, 2, 3, F1, 1, 3, 4 and G1, 2, 3, 4, 5. Two elements are chosen at random without replacement from the set E1 and let S1 denote the set of these chosen elements. Let E2 be E2 minus S1 and F2 be F1 union S1. Now two elements are chosen at random without replacement from the set F2 and let S2 denote the set of these chosen elements. Now G2 is G1 union S2 and finally two elements are chosen without replacement from the set G2 and let S3 denote the set of these chosen elements. Now let E3 equals E2 union S3. Now if it is given that E1 equals E3, find the conditional probability of the event S1 equals 1 by 2. We need to find the value of this conditional probability. Now we are given three sets E1 and E1 is 1, 2, 3. We have F1 and F1 is 1, 3, 4. And then we have this G1 which is 2, 3, 4 and 5. Now first we choose two elements from the set E1 to form this set S1. Now we can choose this S1 in three ways. So this S1, it can be either 1, 2 or 2, 3 or 1, 3. Now it is given that E1 is equal to E3 and E3 is E2 intersection of S3 and E2 is E1 minus S1. So E2 is the remaining element from E1 and if E3 is equal to E1, it simply means that this S3, it must be equal to S1. So this S3, in the first case, it should be 1, 2. In the second case, it should be 2, 3. And in the third case, it should be 1 and 3. So we have three cases, case 1, case 2 and case 3. Now it says we are taking F2 which is F1 union S1. So we'll write F2 which is F1 union S1. Now in the first case, this union will be 1, 2, 3, 4. In the second case, it will be 1, 2, 3, 4. And the third case, it will be 1, 3 and 4. Now from this, we have to choose S2 and then from G1 union S2, we have to form G2 from which we have to select S3. Now since G1 has 2, 3, 4 and 5 and S3 has 1, 2. So in the first case, this should have this G1 intersection S2. It should have 1, 2, 3, 4 and 5. In the second case, when it is 2, 3, there can be two cases possible. Either it will be 1, 2, 3, 4, 5 or it will be 2, 3, 4 or 5. And the third case, since it has 1 here, it should be 1, 2, 3, 4 and 5. Now this first case, if we have to select these two elements in S2, then one of the element, it must be 1 and the other element, it could be any one of 2, 3 and 4. Now here also, if we choose this first case, then it should be 1 and then some element X. And if it is second case, then it should be some elements X and Y other than 1. And in this third case, it should be this 1 and then some element X. So these are the four cases possible in which E1 is going to be equal to E3. Now we'll start calculating. Now in this first case, if we calculate this probability and say it is P1, then first we need to choose two elements from these three elements. It can be done in 2C2 upon 3C2 ways. Then from this set, we have to select S2 in such a way that 1 is always included. So total number of ways is 4C2. And if 1 is always included, then it will be 3C1. Now from this, we have to select S2 which is 2C2 upon 5C2. So this probability will be 1 by 3 and this is 3 by 6 and this is 1 by 10. So it is 1 by 60. So this first case, it is 1 by 60. Now before the second case, we'll calculate actually this third case. In this third case, suppose this is P3. Now first we have to select 1, 3, which again can be done in 1 by 3 ways. Now again for S2, we have to select 2 elements from these 3 elements. It can be done in 3C2 ways, and one of the element, it must be 1. So this other element, it can be selected in 2C1 ways, and then into these 2 out of 5. So it will be 2C2 upon 5C2. Now this is 1 by 3 into 2 by 3 into 1 by 10, and it will be 1 by 45. Now we'll come to this second case when we have this 2, 3. So this is P2 and it'll be this 1 by 3 into, now we have 2 cases. Case 1, if 1 is included, now if 1 is included, there'll be 3C1 upon 4C2 into, now from this we need to select 2, 3. So it'll be 2C2 upon 5C2 plus, and if 1 is not included, then it'll be any 3C2 upon 4C2 into, now this is 2C2 upon 4C2. Now it'll be 1 by 3. Now this is 3 by 6 and this is 1 by 10 plus this is 3 by 6 into 1 by 6. Now this is 1 by 2. So we'll take this 1 by 2 common. So it'll be this 1 by 6 and then 1 by 10 plus 1 by 6, which is 8 by 180 and which is 2 by 45. So this probability is 2 by 45. So in the first case, we get this probability as 1 by 60. In the second case, it is 1 by 45. And the third case, it is 2 by 45. Now we need to find this conditional probability that if E1 equals E3, S1 is 1, 2. So this required probability P will be given by P1 upon P1 plus P2 plus P3. Now this is 1 by 60 and it is 1 by 60 plus 1 by 45 plus 2 by 45. So this is 1 by 60. Now this is 1 by 60. Now this is 3 by 45 and 3 by 45 is 1 by 15. Now this is 4 by 60. So this probability will be 1 by 5. So the value of this conditional probability is 1 by 5 and that's your option A. Now the next question is, let theta 1, theta 2 and theta 10 be positive valued angles such that Z1 is e to the power iota theta 1, Z2 is Z1 into e to the power iota theta 2, which is e to the power iota theta 1 plus theta 2. In the same way, Z3 is Z2 into e to the power iota theta 3, which is e to the power iota theta 1 plus theta 2 plus theta 3. And the same way, we'll have Zk plus 1, which is e to the power iota theta 1 plus theta 2 plus theta k plus 1. And if we look at Z10, value of Z10 will be e to the power iota theta 1 plus theta 2 plus theta 10, and we are given that this is 2 pi. So it will be e to the power 2 pi and cos 2 pi is 1. So basically all these 10 points, they lie on this unit circle, and this is Z10, and then we have Z1, Z2, Z3, Zk, Z9, and angle between them are theta 1, theta 2, theta 3 and theta 10. Now if we look at Zk plus 1 minus Zk, it will be e to the power I theta 1 plus theta 2 plus theta k plus 1 minus e to the power iota theta 1 plus theta 2 plus theta k. Now we take mod sine, then we can write this as mod of e to the power iota theta 1 plus theta 2 up to theta k into mod of e to the power iota theta k plus 1 minus 1. Now this is 1, so we can write mod of zk plus 1 minus zk will be this mod of e to the power iota theta k plus 1 minus 1. Now this is under root of cos theta k plus 1 minus 1 square plus sin theta k plus 1 square. Now this is cos square theta plus sin square theta, which is 1. So it will be 2 into 1 minus cos theta k plus 1, and this is 2 sin theta k plus 1 by 2, and we know that sin theta is always less than or equal to theta, so it will be less than or equal to theta k plus 1. Now if we take this summation, zk plus 1 minus zk will be less than this summation theta k plus 1, and this summation theta is nothing but this is 2 pi. That means this statement P, it is correct. So sum of these modulus will be less than or equal to 2 pi. Now what about Q? Now for Q, what we'll do is we'll first find mod of zk plus 1 plus zk. Now this is mod of zk upon mod of zk plus 1 upon zk plus 1. Now this is 1, and it is e to the power iota theta k plus 1 plus 1. Now again, if we continue in this way, it will be 1 plus cos theta k plus 1. So this value will be 2 cos theta k plus 1 by 2. Now we multiply them, then we can write mod of zk plus 1 square minus zk square will be equal to 4 sin theta k plus 1 by 2 into cos theta k plus 1 by 2, or 2 sin theta k plus 1, and will be less than or equal to 2 theta k plus 1. Now again, if we take this summation, zk plus 1 square minus zk square will be less than or equal to 2 times this summation theta k plus 1, and which is nothing but which is 4 pi. So that means this statement Q is also correct. So the correct option is this option C, both P and Q are true. Now this third question is we need to find area of this region, which is x lies between 0 and 9 by 4, y lies between 0 and 1, x is greater than or equal to 3y, and x plus y is greater than or equal to 2. Now first we'll draw this region. Now x greater than or equal to 3y, so we'll draw this line. X equals 3y, and if we put x as 1, 0, it'll satisfy, so it'll have all the points below this line. Now the second line is x plus y equals 2. So if we draw this line, it'll be this line, x plus y equals 2. If we put origin, then 0 greater than or equal to 2, which is incorrect. So that means we are talking about points lying above this line. So the region contained in between these two lines. Now we'll find this point of intersection. Now we put x as 3y, we'll get y as 1 by 2, and if y is 1 by 2, x is 3 by 2. So this point will be 3 by 2 comma 1 by 2, and this point here, it is 2 comma 0. X lies between 0 and 9 by 4, and 9 by 4 is 2 point something. So x, it should lie between 0 and 9 by 4. Now this point here will be 9 by 4 comma 0. Now this point will be 9 by 4 and 3 by 4. And this point, if we put x as 9 by 4, we'll get y as minus 1 by 4. So this point will be 9 by 4 and minus 1 by 4. And then finally, we have this y, it should lie between 0 and 1. So y, it lies between 0 and 1. So basically, we are talking about this region. Now we have to find area of this region. Now area of this region will be area of this bigger triangle minus area of this smaller triangle. First we'll find area of this bigger triangle will be 1 by 2 and then this height. Now this height is 9 by 4 minus 3 by 2. So it will be 3 by 4. So 1 by 2 into 3 by 4 into this height. This height is 3 by 4 and minus 1 by 4, which is 1, and minus 1 by 2 into area of the smaller triangle. Area of the smaller triangle will be 1 by 4 into 1 by 4. So this is 3 by 8 minus 1 by 32. So it will be 12 minus 1, 11 by 32. So area of this region is 11 by 32, and that's your option A. And now the question is, consider a triangle whose two sides lie on x-axis and the line x plus y plus 1 equals 0. So we have this triangle. Now one of the side is x-axis, that is y equals 0, and the other side is x plus y plus 1 equals 0. Now it says its orthocenter is at 1, 1. So its orthocenter will be at 1, 1. Then we need to find equation of circle passing through vertices of this triangle. Now first we'll find this point of intersection. Now if we put y as 0, we'll get x as minus 1. So this point will be minus 1, 0. Now since this is x-axis and this line, it is perpendicular to x-axis. So here we'll have x equals 1. And if we put x as 1, we'll get y as minus 2. And suppose this point is h, 0. Now product of slope, it is minus 1. So you can write 1 upon 1 minus h into slope of this line minus 1. It will be equal to minus 1. So we'll get value of 1 minus h equals 1, or the value of h is 0. So this point is 0, 0. So we need to find equation of this circle which passes through the points 0, 0, minus 1, 0 and 1, minus 2. Now since it passes through 0, 0, its constant term will be 0. So let the equation be x square plus y square plus 2gx plus 2fy equals 0. Now it passes through minus 1, 0. So if we put x as minus 1 and y as 0, we'll get 1 minus 2g equals 0, or the value of 2g is 1. So this equation will be x square plus y square plus x plus 2fy equals 0. Now this circle, it also passes through the point 1, minus 2. Now if you put x as 1 and y is minus 2, we'll get 1 plus 4 plus 1 minus 4f equals 0. We'll get 2f equals 3. So this equation will be x square plus y square plus x plus 3y equals 0, and that's your option B. Now the next question is, in a triangle ABC, let AB be under root 23. So that means value of C is root 23. BC is 3. So value of A is 3. And CA is 4. That means value of B is 4. Now we need to find the value of cot A, cot B and cot C. Now we can write this as cos A upon sin A, or we can actually write this as 2r sin A cos C upon 2r sin C upon cos B upon 2r sin B. Now cos A is B square plus C square minus A square upon 2. Now 2r sin is A, so it will be 2ABC, and here it will be B square plus A square minus C square upon 2ABC, and here it will be A square plus C square minus B square upon 2ABC. Now this 2ABC will cancel. So now here this a square will cancel and c square will also cancel. So we'll get this as 2b square upon a square plus c square minus b square. Now this is 2. Now what's b square? B square is 16, a square is 9, c square is 23 and minus 16. So it will be 32 and this is 23 plus 9, 32. 32 minus 16 is 16. So this value will be simply 2. So answer to this question is 2. Now the question is number of real roots of the equation 3x square minus 4 mod of x square minus 1 plus x minus 1 equals 0 is. Now if we look at x square minus 1, roots are minus 1 plus 1. So this is plus, minus and plus. So we'll consider two cases. Case 1 when x lies between minus 1 and plus 1. And then the second case when x is either less than minus 1 or when x is greater than 1. Now when x lies between minus 1 and 1, this is negative. So it will be minus minus plus. So we'll get 3x square plus 4x square minus 4 plus x minus 1 equals 0. So there will be 7x square plus x minus 5 equals 0. And when x is less than minus 1 or x is greater than 1, in that case this value will be positive. So we'll get 3x square minus 4x square plus 4 plus x minus 1 equals 0. So there will be minus x square plus x plus 3 equals 0. Now here we just need to find number of real roots. Now in between minus 1 and plus 1, now we take this as some function fx, which is 7x square plus x minus 5. Now if we put x as plus 1, we'll get this value as 8 minus 5, and 8 minus 5 is plus 3. And if we put x as minus 1, we'll get this value as plus 2, and at 0 this value is minus 5. So this graph will start from positive and then it'll take a negative value and then again it'll intersect x-axis. So in between minus 1 and plus 1, it will have two real roots. Now for the second function, we'll consider this as some function gx, which is minus x square plus x plus 3, because this is what we have got after simplification. So after simplification, the first equation is 7x square plus x minus 5 and the second one is minus x square plus x plus 3. Now if you put x as minus infinite, this value will be minus infinite, and since it is a continuous function, it will start from here. So it will be drawn like this. So it will intersect x-axis once here, and in the same way, when x is plus infinite, again it is continuous function. So it will intersect x-axis at one more point. So total number of points at which this graph is going to intersect the x-axis is simply 4. So answer to this question is 4. Now the question is, let u, v and w be vectors in 3-dimensional space where u and v are unit vectors which are not perpendicular to each other, and u dot w is 1, v dot w is 1 and w dot w is 4. Now it says if the volume of parallelepiped whose adjacent sides are represented by u, v and w is root 2, then we need to find this value. Now we know that volume of parallelepiped is given by this box product UVW, and this UVW square will be equal to u dot u, u dot v, u dot w, v dot u, v dot v, v dot w, and w dot u, w dot v, and w dot w. Now it is given that this is root 2. So this value will be equal to 2. Now since u and v, they are unit vectors. So this is 1, and w dot w is 4. Now u dot v we need to find. So we'll take u dot v as x. So this is x and this is x. Now u dot w is 1. So this is 1 and this is 1, and v dot w is also 1. So this is also 1 and this is also 1. So this value will be equal to 2. Now we expand it, we can write 1, and this is 4 minus 1, 3, minus x, and this is 4x minus 1, and plus 1, x minus 1 will be equal to 2. So we'll get this as 3 minus 4x square plus x minus 1, and it'll be equal to 2. So we'll get 4x square minus 2x equals 0. So value of x is either 0 or the value of x is 1 by 2. So either u dot v is 0 or u dot v is 1 by 2. Now it is given that u and v are not perpendicular to each other. That means u dot v, it cannot be 0. So we're left with only one condition, and that is the value of u dot v is 1 by 2. Now we need to find this value. Now this is mod of 3u plus 5v. We'll take square of it. So it'll be 9 mod of u is 1. 25 mod of v is 1 plus 2 into 3 into 5 into u dot v, and u dot v is 1 by 2. So this mod of 3u plus 5v square will be equal to 25 plus 15, 40. 40 plus 9 is 49. So the value of mod of 3u plus 5v will be simply 7. So answer to this question is 7. Now the question is, let alpha, beta and gamma be real numbers such that system of linear equation is consistent, and let M represent this determinant. Let P be the plane containing all those alpha, beta, gamma for which the above system of linear equation is consistent, and D be the square of distance of the point 0, 1, 0 from the plane P. Then find the value of determinant of M and this D. Now if we look at value of delta, this is 1, 2, 3, 4, 5, 6 and 7, 8, 9, and we know that value of this determinant is 0. Now if the value of this determinant is 0 and it is given that the system of linear equation is consistent, it simply means that the system of equation will have infinite solutions. And if it has infinite solutions, then the value of determinant, it must be 0. So what we'll do is, we'll replace any one column with alpha, beta and gamma. So we'll get alpha, beta, gamma minus 1, and this is 2, 5, 8, and this is 3, 6 and 9, and it'll be equal to 0. Now what we'll do is, we'll write C3 as C3 minus C2. So it'll be 1, 1 and 1, and now we'll take, so this is C3 is C3 minus C2, and now we'll take R1 as R1 minus R2 and R2 as R2 minus R3. So we get alpha minus beta, beta minus gamma plus 1. Now this is minus 3, this is minus 3. Now this is 0, 0, gamma minus 1, 8 and 1, and it'll be equal to 0. So we'll get this result as alpha minus beta plus gamma minus 1 equals 0. So the condition is alpha minus 2 beta plus gamma, and it should be equal to 1. Now first we need to find the value of this determinant. So we'll expand this determinant. So this determinant of M will be alpha into 1 and then minus 2, and this is beta and then gamma into 1. So this determinant of M is alpha minus 2 beta plus gamma, which is nothing but 1. So value of determinant of M is 1. Now D is distance of this point 0, 1, 0 from the plane containing alpha, beta and gamma. So one of the plane which contains this point is x minus 2y plus z equals 1. So this distance will be given by 0 minus 2 plus 0 minus 1 upon under root of 1 plus 4 plus 1. So it will be simply 3 by under root 6. Now capital D is square of this distance. So if we square it, we get capital D as 9 by 6, which is 3 by 2. So value of D is simply 1.5. Now the question is, three numbers are chosen at random, one after another with replacement. From the set S equals 1, 2, 3 up to 100, let P1 be the probability that maximum of chosen number is at least 81, and P2 be the probability that minimum of chosen number is at most 40. Now P1 is this probability that maximum of chosen number is at least 81. Now we can find this probability by taking the complement. So we'll find the probability that 1 minus probability that in each of the three cases, this maximum value is 80 or less than 80. So it will be given by 1 minus, now it will be 80 by 100 into 80 by 100 into 80 by 100 for all the three cases. So which is 1 minus, now this is 4 by 5 whole cube. Now this P1 will be 125 minus 64, which is 61 upon 125. Now surprisingly they have asked the value of 625 by 4 into P1. So this value will be 625 by 4 into 61 by 125. So this is 5. So it will be 305 by 4, which is 76.25. Now the 625 by 4, it looks little strange. So either there is some problem with the data or some problem with the problem setup. And if everything is the same, then answer should be 76.25. Now the second case, when it says the probability that minimum of chosen number is at most 40, it will be this case when we have 1 minus probability that minimum of all the three numbers, it is greater than or equal to 41. So it will be 1 minus, and then it will be 60 by 100 whole cube. So it will be 1 minus, and this is 3 by 5 whole cube. So this P2 will be 125 minus 27 upon 125. So now we need to find the value of 125 P2 upon 4. So the value 125 P2 upon 4 will be this 98 divided by 4, which is 49 by 2, and this 24.5. So answer to this first question is 76.25 and the second one is 24.5 if this data and question setup is correct. Now here the question is, consider the lines L1 root 2x plus y minus 1 equals 0 and L2 root 2x minus y plus 1 equals 0 for a fixed constant lambda. Let C be the locus of points such that product of distance of P from L1 and distance of P from L2 is lambda square. If the line y equals 2x plus 1 meets C at 2 points R and S, where distance between R and S is under root 270, and let the perpendicular bisector of RS meet C at two distinct points R dash and S dash, and let D be the square of distance between R dash and S dash. Now the first question is, we need to find the value of lambda square. Now if we find perpendicular distance of point from this line, it will be this root 2x plus y minus 1 upon under root 3, and from the second line it will be root 2x minus y minus 1 upon root 3, and it is given that this is equal to lambda square. So from here we can say this 2x square minus y minus 1 whole square, it should be equal to 3 lambda square. Now it says we need to find point of intersection R and S with the line y equals 2x plus 1. Now this is nothing but this is y minus 1 equals 2x, and if we put y minus 1 is 2x, we'll get this as 2x square equals 3 lambda square, or the value of x is plus or minus root 3 by 2 into mod of lambda. So let this point R be minus root 3 by 2 into mod lambda, and if you put x as minus root 3 by 2 mod lambda, this y will be 1 minus under root 6 mod lambda, and in the same way this s will be root 3 by 2 mod lambda, and if we put this, we'll get this as 1 plus root 6 mod lambda. Now it is given that this distance RS is under root 270. So we can write RS square as, now this is 2 times root 3 lambda, and it will be 6 lambda square, and plus This distance will be 4 into 6, 24 lambda square, and it will be equal to 270. So this is 30 lambda square equals 270, or lambda square equals 9. So the first part is value of lambda square is simply 9. Now we need to find perpendicular bisector of RS. Now first we will find midpoint of RS, and this midpoint will be 0, 1. And if we find slope of this line, then slope of RS will be y2 minus y1. So it will be 2 root 6 upon mod lambda divided by this, which is 2 root 3 by 2 mod lambda. Now this lambda will cancel, this 2 will cancel, this root 3 will also cancel. So this slope will be equal to 2. So slope of r dash s dash will be minus 1 by 2. So equation of this line will be y minus 1 equals minus 1 by 2x. Now we need to find its point of intersection with this curve when the value of lambda square is 9. So this curve is actually mod of 2x square minus y minus 1 whole square, and it is equal to 27. Now we put y minus 1 as minus x by 2, will be x square by 4, 2x square minus x square by 4 equals 27. So we'll get 8 minus 1 7. So there will be 7x square by 4 equals 27. So we get the value of x is plus minus 6 into root 3 by 7. Now if this is x1 and x2, then we can find x2 minus x1 will be 12 into root 3 by 7, and y2 minus y1 will be minus 1 by 2 into 12 root 3 by 7. So this square of distance will be 144 plus, now this is 6 square, which is 36 into 3 by 7, which is 77.14. Now the question is, we are given this function fx, which is x square minus 3x minus 6 upon x square plus 2x plus 4, and we need to find which of the following statements is true. Now this is a simple question. What we'll do is we'll differentiate this function. If we find f dash x, this f dash x will be 5x into x plus 4 divided by x square plus 2x plus 4 whole square. So it has two critical points, minus 4 and 0. So this is plus minus n plus. Now when x lies between minus 2 and minus 1, this function, it is a decreasing function. So this option A is correct. And when x is greater than 0, it is an increasing function. So this option B is also correct. Now we need to find a range of this function. Now f minus 4, it will be 16 plus 12 minus 6, and here will be 16 minus 8 plus 4, which is 22 by 12, and that is 11 by 6, and the value at 0 will be simply minus 3 by 2, and if we take this limit x tends to plus or minus infinite, this limit will be simply 1. So range of this function will be from minus 3 by 2 to 11 by 6. That means this option D, it is incorrect, and its codomain is R. So this f is not onto. So the correct options are A and B. Now here the question is, let E, F and G be three events having probabilities 1 by 8, 1 by 6 and 1 by 4, and their intersection is 1 by 10. Then which of the following is correct? So we have three events, E, F and G. So this is E, F and G. So let this be E, this is F, and let this be G. Now it is given that probability of E is 1 by 8, probability of F is 1 by 6, and probability of G is 1 by 4, and their intersection, it is given as 1 by 10. Then which of the following is correct? Now we know that probability of E intersection F will be less than or equal to minimum of probability of E and F, and in between E and F the smaller value is 1 by 8, so it will be always less than 1 by 8. In the same way, probability of F intersection G will be less than smaller value between F and G, which is 1 by 6, and the same way probability of E intersection G will be less than or equal to 1 by 8. Now if we look at probability of E union F union G, we know that this probability will always be less than probability of E plus probability of F plus probability of G. Now probability of E is 1 by 8, F is 1 by 6, and this is 1 by 4. Now this is 24, 3, 4 and 6, so it will be simply 13 by 24. So this probability of E union F union G, it is less than or equal to 13 by 24, and that's your option C. Now if we look at this probability, which is probability of E intersection F intersection G naught. Now probability of E intersection F intersection G naught is actually this probability. This probability is equal to probability of E intersection F minus probability of E intersection F intersection G. Now this is probability of E intersection F minus, and this probability it is 1 by 10. Now we know that probability of E intersection F, it is always less than or equal to 1 by 8. So its maximum value is 1 by 8. So it will always be less than or equal to 1 by 8 minus 1 by 10, which is 1 by 40. That means this option A is also correct. Now we look at this option B. Then option B is probability of E complement intersection F intersection G. Now it will again be probability of F intersection G minus probability of E intersection F intersection G. Now maximum value of F intersection G is 1 by 6. So it will always be less than or equal to 1 by 6 minus, and this intersection is 1 by 10. So it will be 4 by 60, which is 1 by 50. So that means this option B is also correct. Now if we look at this probability, which is E naught intersection F naught intersection G naught, so it will be this region, and this probability will be given by 1 minus probability of E union G union F. Now this probability will be minimum when this value is maximum. So it will always be greater than or equal to 1 minus 13 by 24, which is 11 by 24. So that means this option D is incorrect. The question is, we are given three matrices E, P and F, and Q is a non-singular matrix of order 3 cross 3, then which of the following statements is or are true? Now if we look at this P, then if we find P square will be 1 0 0, 0 0 1 and 0 1 0, and this is 1 0 0, 0 0 1 and 0 1 0. So this value will be 1 and then 0 0. Here will be 0 1 0, and then it will be 0 0 and 1. So basically value of P square, it is I. So P square is an identity matrix. Now if P square is an identity matrix, then for this F we can write this FP into P. If we multiply it with P, we can write PF equals EP, and by simple multiplication we can verify that this is correct. So this option A, it is correct. From this option A, what we can also infer is, if we multiply P from the right hand side, then we can also write this E as PF and P. So we have these conditions that F is PEP and E is PFP and P square is I. if we look at determinant of E, it is 1, 2, 3, 2, 3, 4, 8, 13, 18. Now we subtract this C3 minus C2, so it will be 1, 1, 5, and here it will be 1, 1 and 5, and the value of this determinant is 0. In the same way, value of f is also 0. So determinant of E equals determinant of f, and it is equal to 0. That means this option C, it is incorrect. Now since determinant of E and determinant of f is 0, if we look at this right hand side, then determinant of E into determinant of Q plus determinant of P, determinant of f, and determinant of Q inverse. Now this is 0 and this is 0. So this right hand side will be 0. And if we look at this left hand side is determinant of EQ PF into Q inverse. Now we know that this E is PF into P. So we can write this as PF PQ plus PF into Q inverse. Now if we take PF common, so we can write mod of PF into mod of PQ plus Q inverse. Now mod of F is again 0. So that means this option B is also correct. Now since P square equals to I, that means P is self-inverse. So P inverse, it is equal to P. So this P inverse EP plus F, it is PEP plus F, and PEP is nothing but it is F. So it will be nothing but 2F. So this entry is 2F, and the same way this is 2E. Now sum of diagonal entries of E is 18 plus 1 plus 3, which is 22, and diagonal entries of F is also 22. So that means this option D is also correct. So the correct options are A, B and D. Now the next question is very standard question. We can write this S and X as this summation tan inverse K plus 1x minus Kx upon 1 plus Kx into K plus 1x, which is this summation tan inverse K plus 1x minus tan inverse of Kx. Now we put the value of this summation, then it starts from 1, so it will be tan inverse 2x minus tan inverse x plus tan inverse 3x minus tan inverse 2x, and finally it will go up to tan inverse n plus 1x minus tan inverse nx. Now all these, they'll cancel, so we'll get this S and X as tan inverse n plus 1x minus tan inverse of x, which is tan inverse a minus b. So it will be this nx upon 1 plus a into b. So it will be n plus 1 into x square, and that's your function S n x. Now the first part is we need to find S tan x. Now this S tan x will be tan inverse tan x upon 1 plus 11x square. Now since x is greater than 0, we can write this as cot inverse 1 plus 11x square upon tan x, and we know that cot inverse x is pi by 2 minus tan inverse x, so it will be pi by 2 minus tan inverse 1 plus 11x square upon tan x. So that means this option A, it is correct. Now if we look at this option B, then this cot of this limit n tends to infinite. Now if we take limit n tends to infinite, this limit will be tan inverse of, now coefficient of n, here it is x and here it is x square. Now this x and x will cancel, so we'll get this as cot of tan inverse of 1 by x, and since x is greater than 0, it is nothing but it is cot of cot inverse of x, which is nothing but x. So that means this option B is also correct. Now we look at this S3x. Now it says S3x equals pi by 4 has a root n 0 to infinite. Now S3 is tan inverse 3x upon 1 plus 4x square, and if we take it equal to pi by 4, then we'll get this as 4x square minus 3x plus 1 equals 0. Now for this, if we find D is 9 minus 16, which is less than 0. That means this is always positive. So this equation, it won't have any real root. So that means this option C, it is incorrect. And then finally, this D, which is 10 SNX. Now if you look at this 10 SNX, now this 10 SNX will be nx upon 1 plus n plus 1x square. Now if we take this as y, and if we differentiate this function dy by dx, then it will be equal to 1 minus n plus 1 x square into n upon 1 plus n plus 1 x square whole square. So here we'll get one root, and which is 1 upon under root of n plus 1. Now this is plus and this is minus. So this function, it will have a local maxima at 1 upon under root n plus 1. Now if we find its value at 1 upon under root n plus 1, this value will be n upon under root of n plus 1 by 2, which is n upon 2 under root n plus 1. Now this is greater than n upon 2 root n, which is under root n by 2. So this value is always greater than 1 by 2, not less than 1 by 2. So that means this option D is incorrect. So the correct options are A and B. Now the question is, for any complex number W, let alpha beta be real numbers such that all complex numbers satisfying argument of z plus alpha upon z plus beta equals pi by 4 lie on this circle. Now in complex number, you have already studied that this equation, it represents portion of a circle whose chord is minus alpha minus beta, and which subtends an angle pi by 4 in the segment. Since alpha and beta, they are real numbers, that means this line is y equals 0 line, and this equation, it is represented by this curve. So if we have to find alpha and beta, we just need to find point of intersection of x-axis with this circle. So if we put y as 0, we get x square plus 5x plus 4 equals 0. So we get x plus 1, x plus 4 equals 0. So value of x is minus 1 or value of x is minus 4. So that means value of alpha is either 1 or 4, and value of beta is either 4 or 1. So the correct options are alpha into beta will be 4 and beta can be 4. So the correct options are B and D. Now the question is, let E and F be two matrices such that I minus EF is invertible and G is inverse of this matrix. Then we know that G into I minus EF is equal to I minus EF into G, and it will be equal to I. So we can write G minus GEF will be equal to G minus EFG, and it should be equal to I. Now we compare these two, then we can have this result C, which is EFG is equal to GEF. Now if you look at this option A, it is I minus FE into determinant of FGE. Now this is determinant of IFE into determinant of FE into determinant of G. Now from this first one, if we take this determinant, we can write determinant of I minus EF into determinant of G, it is equal to 1. So this is equal to determinant of FE. That means this option A is also correct. Now if we look at this option B, if we multiply it, we can write I minus FE plus FGE and then minus FE into FGE. We know that we can write EFG as G minus I. So we write EFG as G minus I. So it will be I minus FE plus FGE minus F, and this is G minus I into E. So it will be I minus FE plus FGE Now this is FGE and plus FE. Now this FE will cancel, FG will also cancel. So this is equal to I. That means this option B is also correct. Now if we look at this option D, it is 1 minus FE minus FGE plus FEF GE. Now again we write EFGS G minus I, so it will be 1 minus FE minus FGE, and it is F and EFG is G minus I into E, so it will be 1 minus FE minus FGE minus FE. Now FG will cancel, 1 minus 2 FE, that means this option D is incorrect. So the correct options are A, B and C. Hello and welcome to the world of mathematics. I present my website www.mathsmerizing.com and my YouTube channel Mathsmerizing for your kind perusal. If you like them and are inspired by the possibilities, then consider subscribing and sharing it with someone you know who might benefit from it. Thank you.